change the electronics on my computer. So let me back up a little bit, so bear with me. So CRBC is partnering with the Environmental Learning Center at Clackamas Community College. Workshop attendees will receive a science certificate of completion for each session. If you'd like a certificate of completion, add your contact information to our Journey Down the Clackamas Conference Networking Google Sheet and indicate you'd like a certificate in the G column, and we'll forward your contact information to Clackamas Community College. So I'd like to share a few ground rules before we introduce our special guests. Please keep your microphones on mute unless invited to participate, and you can keep your cameras off if you like. And that'll also help us save some bandwidth for our presenters and greatly reduce the carbon footprint of our meeting. So we'll have two presenters this evening with a brief Q&A after each presentation. But if you have a really burning question or a clarification that you'd like answered during the presentation, please feel free to type it in text chat. But just to kind of keep the program rolling, if you can defer your questions till after each presenter, that would be great. And then we'll have a final wrap up after both presenters are done. So please type your questions in the chat, as I mentioned, and we'll select questions from there. However, if your question is long and or complex, please feel free to ask it in the audio, and feel free to send direct chats to friends you're seeing in the participants list if you like. So now we'll start our presentation for this evening, and please remember to type your questions in the chat, keep yourself muted, and we'll answer questions at the end of each presentation. So the webinar will extend to about 7:15 tonight, or maybe just a little shorter, with additional questions afterwards, as I mentioned. So tonight I'd like to introduce our presenters. Kyla Zaret is an ecologist and GIS analyst with the Institute for Natural Resources and a PhD candidate in the Global Environmental Change Lab at PSU. And over the past 20 years, she's conducted field ecology studies on a variety of systems and subjects, from seabirds in the Gulf of Maine to zooplankton in the Antarctic and headwaters, streams, amphibians here in the Pacific Northwest. The wetlands are her passion, so we're lucky to snag her for tonight. So this presentation, she's excited to share an introduction to wetland ecology with a focus on wetlands in the upper watersheds of the Clackamas Basin. And then following Kyla, Michael Krochta is the Forest Watch Director for BARC, a Portland-based nonprofit whose mission is to transform Mount Hood National Forest into a place where natural processes prevail, where wildlife thrives, and where local communities have a social, cultural, and economic investment in its restoration and preservation. In 2022, he will be joining the Earth, Environment, and Society program at Portland State University to study the influences of natural disturbance, land management, and climate change on water availability in our region. So now let's welcome Kyla and Michael as they present about wetlands and beavers. So take it away, Kyla.
Thanks, Dave. I'm just going to stop my video while I talk, and then I'll put it back on for questions. And let me share my screen.
Looks good, Kyla.
Thank you. Just going to arrange things a little bit. All right. Well, hi, everyone. Thanks for this opportunity to share with you our work on wetlands and beaver habitats in the upper Clackamas River Basin and Mount Hood National Forest. Before we get started, we'd like to say a quick thanks to the CRBC for organizing the Journey Down the Clackamas Conference and inviting us to participate. Thanks as well to the Drinking Water Providers Partnership, including the Clackamas Ranger District and the Forest Service, for supporting our work. Here's an overview of our presentation. There are two parts. In the first part, I'm going to give a basic introduction to wetland ecology and wetlands benefits. Then I'll summarize some of the goals and methods of our wetland and beaver restoration project. And finally, I'll show you some of the water level data that we've collected to date. In the second part of the talk, Michael will get into the ecology and restoration needs of those wetland building critters that people tend to love or hate, the beaver. He'll also talk about BARC's ongoing efforts to identify locations of high quality beaver habitat. Excuse me. So let's start with the question, what is a wetland? When we think of wetlands, we often think of places with standing or ponded surface water. Some wetlands are indeed permanently or intermittently flooded, like cattail marshes or Sitka spruce swamps. And others are characterized by water tables that are very close to, but just under the surface at all times, like bogs. But many wetlands, or maybe even most wetlands, are not permanently inundated and may in fact be dry for much of the year, like forested bottomlands, vernal pools, or the wet meadow pictured here. So how can we identify wetlands if not by water presence? Well, the answer isn't straightforward. According to the manual titled Classification of Wetlands and Deepwater Habitats in the US, there is no single, correct, indisputable, ecologically sound definition for wetlands, primarily because of the diversity of wetlands and because the demarcation between dry and wet environments is dynamic and lies along a continuum or gradient. This gradient of wetness can make wetland boundaries difficult to distinguish from other types of ecosystems. In general, we can think of wetlands as occupying transitional zones between terrestrial and aquatic environments, shown here on the left by well-drained forested uplands, and on the right by permanently flooded deepwater habitats. Riparian areas are also transitional zones. Sometimes the term riparian area and wetland are used interchangeably, but I like to encourage folks to think of them as different ecosystems that are driven by distinct processes that have different functional roles on the landscape. That said, the boundaries that separate riparian areas from uplands or wetlands can be subtle. We can get a better understanding of those subtle or overlapping boundaries by zooming out to the landscape scale and looking at the landscape in profile. In the middle and lowest part of the landscape, we see a channel that represents the deepwater habitat of the river. As we move away and upslope from the channel to the right, we encounter an area where wetland and riparian boundaries overlap. In this instance, the riparian area links the river and wetland to the upland, and it widens the ecotone or the transition zone from aquatic to upland system. If we start at the channel and move to the left, we encounter a wetland positioned in a depression that's buffered on both sides by riparian areas. Notice that the riparian areas develop further upslope, away from where the water level is expressed in the wet depression. In general, riparian areas tend to be inundated by surface water less frequently and for shorter durations than wetlands. And as a result, the plant communities of these types of ecosystems tend to be dominated by different species. Riparian plant communities can often be quite similar to that of adjacent forested uplands, though they tend to be more lush and may have a greater diversity of species, especially woody deciduous plants. In the photo on the left, you can see an alder-dominated riparian area with a dense understory of ferns and forbs. In contrast, wetlands are dominated by plants that can handle long periods of water presence, such as the sedges in the photo on the right. While riparian areas can be found along the fringes of ponds and lakes, we most often think of them as corridors that form along the linear landscape features of streams and rivers. The dynamics of those riparian areas are strongly influenced by geofluvial processes associated with flowing water, or lotic systems. You can see that the creek on the left is strewn with cobbles and boulders, and there's a small riffle in the bottom right. Many wetlands, on the other hand, are lentic systems that are associated with still or slow-moving, low-gradient water bodies. In the wetland on the right, the stream channel is composed of fine organic and mineral soil, rather than the coarse rocks carried by faster-moving waters. You may have noticed that I labeled the wetland as flusterine. Flusterine wetlands are any non-tidal wetland that is not confined within the shores of a lake or the banks of a river. All of the wetlands that we've been surveying in upper watersheds of the Clackamas are flusterine systems. Now let's take a look at the key defining characteristics of wetlands. If we want to know whether a site is a wetland ecologically, we look for the presence of at least one of three sets of wetland indicators. We look for water, whether currently on site or signs of past inundation, hydric soils, and hydrophytic or water-loving vegetation. Now, if we wanted to delineate wetland boundaries for a regulatory purpose under the Clean Water Act, we need to find evidence for all three. But to identify whether a site is functioning like a wetland, it's usually good enough to find just one. Though water drives wetland structure, composition, and function, it's important to keep in mind that the hydrology of the site, the soils found there, and the plants growing there are all interrelated. There are numerous feedbacks among the three, which create the unique chemical and biological conditions that characterize wetlands. For example, water presence affects soil biogeochemistry by creating an anaerobic or oxygen-depleted environment. The lack of oxygen slows activity of soil microbes and thus rates of decay of plant litter and other organic compounds. And as a result, organic soils like those pictured in the top left can form on top of mineral soils. Waterlogged soils, in turn, whether organic or mineral, directly affect plants by limiting their access to oxygen, which they need for respiration. So most upland plants will die if anaerobic conditions last for even a few weeks during the growing season. This is why wetlands are dominated by hydrophytic plants. These plants have special adaptations for dealing with the low oxygen and often low nutrient conditions of wet sites. Here are a few of those adaptations. They include large air-filled cavities and stems that allow for the exchange of gases between plant tissues above and below water, like in cattails. And they also include rapid, multiple stem growth and roots close to the surface, like in willows, which increases the amount of surface area exposed to air. Finally, they can include the nutrient capturing strategies of carnivorous plants like sundews. To aid wetland identification, plants are categorized according to their likelihood of occurring in wetland soils. There are 5 widely used categories. Facultative upland plants can survive in uplands or wetlands, but they're more likely to be in uplands. Plants that are facultative are those that have about an equal chance of appearing in uplands or wetlands. Facultative wet plants are more likely to be in wetlands, and obligatory wet plants are found only in wetlands. In Oregon, there are almost 600 plant species that have FAC-wet or obligatory status. And you can use the US Army Corps of Engineers website shown here to look up the wetland indicator status of specific species. Before we move on, I want to show you some of the plants that we commonly find in wetlands in the upper Clackamas. Tree species include alders and spruces. Some common shrubs are Douglas spirea, a whole bunch of willows, and bog bilberry, which is a species of huckleberry. And we find a lot of different species of sedges, rushes, and grasses, all of which are graminoids. Now I'd like to get into some more detail about wetland hydrology, since again, this is the driving force behind many other wetland processes and the resulting benefits for human and non-human communities. When we talk about wetland hydrology, we're especially interested in the amount and pattern of water presence, because these factors determine whether a wetland is formed and maintained at a given site, as well as the type and functioning of that wetland. The term water regime is used to summarize the amount and pattern of water presence. A wetland's water regime is characterized by the depth, duration, frequency, daily fluctuation, and seasonal timing of water inputs and outputs. In other words, water regimes summarize when and how often water arrives at a site, how deep that water gets, and how long it stays. The vernal pool shown in the photos on the left can be said to have a seasonal water regime. It fills with rainwater in the spring, dries out by the end of the summer, and again fills with rain come the fall. Water regimes let us conceptually describe the wetness of a site and how that changes over time. But we can also calculate changes in a wetland's water volume by identifying and summarizing all of the water inputs and subtracting all of the water outputs. In blue on the left side of the figure, you can see potential water sources or inputs. Those include groundwater, surface water inputs like runoff from surrounding slopes or overbank flooding from streams and ponds, as well as precipitation in the form of rain or snow. Here on the right are the outputs, again via groundwater, surface water, and then also evapotranspiration. There are many factors that can affect a particular wetland's water budget, and these can occur at scales from the greater landscape to the catchment directly surrounding the wetland to features within a wetland's boundaries. Really, anything that affects water connectivity, anything that slows or prevents water from entering or leaving a site will influence the water budget. For example, greater runoff is expected from steeper slopes, yet the type and density of the vegetation can slow water down. Likewise, the composition and structure of vegetation surrounding wetland may slow evapotranspiration through the shading offered by tall shrubs and trees. Within a wetland, the various textures and depths of soil layers can affect water depth. For example, clayey soils have very fine pore spaces that drain slowly compared to sandy soils with large pore spaces. Natural and artificial structures also affect water connectivity. Upstream headgates can reduce or inflate water volumes. Ditches can artificially carry water out of a site, and roads or beaver dams can impede water from leaving sites, thus increasing the extent, duration, and depth of inundation. Now let's look at how landscape position affects water inputs and outputs to wetland sites. Here, we're in the middle of Clackamas River watershed near the Ripplebrook store and the junctions of Highway 224 and roads 57 and 46. You can see that there are quite a few riparian and plustron sites in this scene. The riparian sites are all along streams or the Clackamas River, and they tend to be longer and more narrow than the plustron sites. The plustron wetlands occur in a greater variety of landscape settings. For example, we see some sites, like the one to the north of the Ripplebrook store, that's in a slight depression at the base of a steep hill, and that's likely to be influenced by groundwater expression at the slope break, and also to hold precipitation given its concave shape. There are also plustron wetlands at the headwaters of small stream channels, and there are sites that are usually called isolated because they aren't connected to the stream network via a surface water channel. One example is Ward's Meadow. This site is actually a very cool peatland, which is a type of wetland that's saturated to the surface year-round, and whose soil profile includes deep organic layers. Ward's Meadow sits below a steep slope and on a flat bench above the Clackamas. The flat terrain and groundwater expression from the slope break have allowed the development of peat soils that are over 1 meter in depth. And the vegetation community includes areas dominated by bog-associated plants like the bog bean. To the south of Ward's Meadow, we find a very different type of wetland. It's located on a slight slope and includes a narrow, slow-moving channel, an area of ponded water, and a few different vegetation zones. In the background of the photo, you may be able to see one zone dominated by shorter sedges, and behind that, some taller cattails. As we've seen so far, both external and internal factors create the combination of water, soil, and plant components that make up a given wetland. Wetlands with similar patterns of water amount and presence and similar soil profiles and vegetation communities also tend to offer similar ecosystem services or wetland benefits. For example, wetlands can be hotspots of biodiversity. Over 140 species of plants have been identified at Anvil Lake, which is another peatland site in the Upper Clackamas. Wetlands are also known as crucial places for breeding amphibians, and there are high numbers of invertebrate species that use these ecosystems. And also there are some birds that depend on these places too, like the willow flycatcher, which is a species of concern in Oregon. On the landscape scale, we're just beginning to understand the roles that wetlands can play when it comes to fire. This map shows soil burn severity in the Ward's Meadow area following the Riverside Fire of 2020. You can see that 3 of the 4 wetlands, including Ward's Meadow, seem buffered by the blue low severity areas. It's possible that the wet conditions in these sites help to break the fire spread from the east, either directly through a change in microclimate or by the absence of tall trees, thus preventing the fire from spreading through the canopy. Finally, a wetland's position on the landscape, its characteristic water regime, and biophysical factors like its shape and depth contribute to a wetland's ability to trap and store water, thus helping to prevent floods during big storm events or helping to maintain water availability during times of drought. When researchers estimate wetland benefits like flood attenuation, they often create simulation models in which groups of wetlands are taken out of a river catchment, and then they compare peak flows with and without those wetlands. But what about the roles of individual wetlands? How does the water storage capacity of that wetland to the south of Ward's Meadow compare to the capacities of the other wetlands in the same stream catchment, or to the capacity of Ward's Meadow itself? Those questions are some of the motivations behind the Wetland and Beaver Habitat Project that Michael and I are working on in the Clackamas Basin. We're interested in quantifying specific ecosystem services of individual wetlands so that we can recommend which sites would be best to prioritize for restoration activities. The project is designed with our recognition that beavers play important roles in creating and maintaining some wetland sites, but that today's beaver presence in Mount Hood is much lower than what it had been historically. Here are our specific project goals. One is to establish accurate baseline information regarding the locations, sizes, and types of wetland sites in the project area. 2, to identify and rank sites that are suitable beaver habitats. 3, to estimate the water storage capacity of individual wetland sites with a focus on highly ranked beaver habitat. And 4, to synthesize the results to make management recommendations. I'm going to tell you a little bit more about goals 1 and 3, and then later on, Michael will tell you about goals 2 and 4. Here's a map to orient you to our project location. We're working in the 2 watersheds that are in purple, the Middle Clackamas and the Oak Grove Fork Clackamas River watersheds. These watersheds overlap Estacada's drinking water source area, which is shown in teal stripes. You can also see the Riverside Fire Perimeter, which is shown in orange. And I've also included the yellow diamonds, which are where beaver habitat surveys and/or wetland verification surveys have been completed to date. Our first project goal is to get a handle on where and what kinds of wetlands are found in the project area, which involves both mapping and classification. Now, there are a variety of ways of classifying wetland ecosystems. These vary from classifications that are widely applicable across geographies to those that are specific to a given state or ecoregion. Wetland classifications can be based on characteristics that focus on landscape position, like the HGM or hydrogeomorphic system, to those that key in on the species of plants that define a wetland community. We're going to focus on the coordinate classification system, but to learn about others, including the major wetland and riparian types in Oregon, I strongly recommend that you take a look at the wetland content on Oregon Explorer. The coordinate classification system is the standard classification system for wetland mapping across the US. The system was first developed in 1979 by the Coordinate et al. And revised in 2013 by the Federal Geographic Data Committee. To date, national wetland inventory mapping has been completed for most of the US. Unfortunately, the majority of mapping in Oregon occurred in the 1980s or earlier, as you can see on the map on the top left. So the NWI doesn't fully represent number, types, or boundaries of wetlands remaining today. In addition, the original NWI mapping was based on relatively low resolution base imagery, leading to mapping errors. The map on the right is again of the Ward's Meadow area, but you can see that the wetlands in the center of the scene weren't mapped at all. They're lacking polygons. So this is why our project goals include updating the NWI mapping across the study area. Towards that end, volunteers have been helping us to field check digital wetland mapping that we do in the office. We've conducted several online and field-based trainings on wetland classification since 2020, and we'll be putting on more this coming field season. They're open to the public, so if you want to get your feet wet and your hands mucky, please check out BARC's events page for training dates, videos, and a calendar of activities. The next slides I'll present come from one of our trainings on the coordinate system. As you'll see, it's full of technical details. These help wetland mappers meet the National Wetland Inventory standards and create consistent mapping products that allow someone in the desert Southwest, for example, to look at a coordinate code and quickly understand the type of wetland or wetland zones that characterize a site here in the Pacific Northwest. National Wetland Inventory mappers use high-resolution aerial imagery to hand-digitize polygons around distinct zones that make up a wetland. NWI standards have the minimum mapping unit as half an acre, so that's the smallest zone that could be drawn, even if finer scale features are visible. As an overview, the coordinate classification system first separates wetlands into major systems, and then separates systems into subsystems, classes, and subclasses. To those, water regime and special modifiers are added. All of those components are captured by a coding convention built of letters and numbers, which is assigned to each wetland polygon. These letters and numbers ultimately represent the broad landscape context of the wetland, its vegetation structure, its water regime, and any natural or anthropogenic modifications to the wetland. I'm going to break this down a bit more to give folks an introduction to interpreting coordinate codes. And as a warning, the next slides are a bit dry and wordy, so please bear with me. First, coordinate delineates 6 major systems, including marine, estuarine, riverine, lacustrine, palustrine, and riparian. We're going to focus in on the palustrine system to help keep things simple, and again, because most of our sites have been palustrine sites. Most palustrine wetlands are non-tidal wetlands. They're dominated by trees, shrubs, and persistent emergent or non-woody vegetation, like graminoids and forbs. Palustrine wetlands also include those that are lacking vegetation, but in that case, they need to be 20 acres in size, and the deepest part of the wetland should be less than 2.5 meters at low water. Cluster wetlands don't have subsystems, but there are classes and subclasses. Clustering classes include rock bottoms, unconsolidated bottoms, aquatic beds, unconsolidated shores, emergent, scrub, and forested. So let's take a closer look at some of these. The first three classes are our ponds. They differ in terms of the nature of their substrates and the percent cover of their vegetation. The unconsolidated shore class often applies to the shoreline around ponds, but it can also be used for some vernal pools as well as snowmelt depressions. Unconsolidated shores are characterized by having less than 30% vegetation cover. Our more familiar wetlands are dominated by emergents, shrubs, or trees. These quadrant classes are defined by the height of the tallest vegetation layer, and in each case, vegetation cover must be more than 30%. So for a cluster and emergent wetland, sedges, rushes, grasses, and/or forbs need to form the tallest layer. Cluster and scrub wetlands are those where the tallest vegetation is woody, but less than 20 feet tall. And forested wetlands are dominated by woody vegetation greater than 20 feet tall. National mapping standards only require that subclasses are used for cluster and emergent scrub, and forested wetlands. For these, subclasses are based on the persistence and the structural form of a wetland's vegetation. For cluster and emergent wetlands, vegetation is considered persistent, but the stems and leaves of the wetland plants are evident all year long above the surface of the soil or water, even if they're dead. But they're non-persistent if there's a dormant period with absolutely no sign of emergent vegetation. For scrub, and forested wetlands, vegetation is characterized as either broad-leaved or needle-leaved and deciduous or evergreen. The class of wetland determines which water regimes may be applicable. Here, I'm only displaying some of the wetland classes that we talked about. For aquatic beds, water regimes may be classified as seasonally flooded, semi-permanently flooded, intermittently flooded, permanently flooded, or artificially flooded. And there are even more options for emergent scrub, or forested wetlands. As we advance through the alphabet, the water regime letters represent more persistently wet conditions, from A, temporarily flooded, which could mean the site is inundated for only 2 to 3 weeks during the growing season, to H, permanently flooded, or flooded across the entire year. And finally, here are the special modifiers that we can use to indicate whether a wetland zone has been influenced by beaver or human activity. The codes include beaver, partly drained or ditched, farmed, managed, diked or impounded, artificial substrate, spoil, or excavated. Now let's look at an example of how to apply the coordinate system. The area shown in the photo is part of the northwestern arm of the wetland complex that includes Little Crater Lake. On the right, you can see part of the form that we use when conducting wetland mapping verification surveys in the field. So first, we'll delineate different zones of vegetation structure and water regime. There are 3 different zones. Next, we'll figure out the coordinate codes starting with the wettest zone, the pond. Here, the system is palustrine because it's non-tidal and less than 20 acres. There's no subsystem because it's palustrine. The class is aquatic bed because, though hard to see in this image, there's around a 30% cover of pondweed and pond lily. The water regime is permanently flooded H because even in late August, following the summer drought, there was surface water that covered the majority of the pond area. The muck bottom was only exposed at the very edges and in only some places. And finally, we add a B modifier to indicate that the site is impounded by a beaver dam. That dam runs along the entire south-southwest edge of the wetland. Altogether then, this zone gets the code PABHB for palustrine, aquatic bed, permanently flooded, beaver modified. Now let's look at the zones surrounding the pond. The system is palustrine because it's on tidal and it's dominated by persistent vegetation. The class is emergent because the zone is dominated by graminoids, which are non-woody. They make up the tallest vegetation layer and their cover is greater than 30%. The subclass is persistent because live or dead sedge stems will remain throughout the year. Finally, the water regime is seasonally flooded / saturated, or E, because the soil surface was waterlogged throughout the summer and surface water was present in the late fall when the rains came. And we'd expect the same at the start of the growing season. And again, we add a beaver modifier. This whole zone gets the code PEM1EB for palustrin, emergent, persistent, seasonally flooded / saturated, beaver modified. In the interest of time, I'll just show you that the coordinate code for the third zone is PSS1DB for palustrin, scrub shrub, persistent, continuously saturated, beaver modified. So let's move on to another one of our project goals. In addition to wetland mapping verification, BARC volunteers have been helping us with water level and vegetation monitoring. They've installed vegetation phenology plots and water level monitoring wells, which are the PVC tubes. And they've also made repeat visits to sites to manually measure water heights or to read out the data from loggers suspended in the wells. To date, we've deployed 24 data loggers, which record water level and water temperature every hour. The loggers were installed at 11 sites, though 5 of those are now within the Riverside Fire burn perimeter, and we haven't yet been able to get back in to retrieve the data from 4 of them. In general, we've been installing up to 3 wells with data loggers per site. Usually we install 2 surface water monitoring wells, one in the zone with the deepest water and longest duration water regime, like in ponds, and one in the outlet channel. We also install 1 groundwater well, usually in the wettest coordinate zone with emergent scrub shrub vegetation. This table summarizes the sites in which we've installed data loggers. I just want to point out that our longest time series of water level data come from wells and sites that may have burned. If we get back into those sites and the loggers haven't been damaged, we may be able to have more than 2 years worth of data from some of our sites. This will give us a good start at understanding how surface and groundwater levels fluctuate on daily, monthly, seasonal, and even annual timescales, and thus give us a good sense of the variability in water storage volumes. In the next slide, I'll show you a few of the shorter time series of water level data, and that's where I'll wrap up. In the plot shown here, we're looking at average daily water level data along the y-axis and the date at weekly intervals along the x-axis. Each of the lines represents the water level from one well, and they're color-coded by site. Data from the Little Crater Lake Dam 1 site are in green, and there's a photo of that site at the bottom left. Data from the Little Crater Lake Dam 2 site are in orange, and data from the Sam Creek site are in purple. The lines in the plot are also symbolized by the location of the well, whether in an outlet channel C, in a pond P, in an emergent zone EM, or in a scrub shrub zone SS. Water levels increased in all of the wells from the beginning of September to mid-November, but they did so at different rates and by different amounts. If you look at the solid green line at the top half of the plot, you can see that one of the largest changes in water levels occurred in the outlet well at the Little Crater Lake Dam 1 site, where surface water increased by about 60 centimeters. Now take a look at the purple dashed line near the bottom of the plot. A similar increase, but in groundwater, occurred in the well in the scrub shrub zone at the Sam Creek site. In contrast, the solid purple line from Sam Creek shows that surface water levels barely changed across the sampling period. What's most interesting to me about these data so far is that changes in water level weren't synchronized across or even within sites, even though all of them experienced the same weather events. This suggests that we do indeed need to examine water storage or other wetlands benefits on a site-by-site basis. I'm still hoping, though, that we'll find some trends by wetland type, and that this will let us use our wetland mapping and monitoring data to estimate water storage volumes across many other sites beyond the 11 that we've been monitoring intensively. And with that, I will wrap things up. As Dave mentioned, if you have burning questions, then I can take some now. We are eager to move on with Michael's part of the presentation. And so if you can, I encourage you to put those in the chat, and then we'll have a big question and answer session at the very end.
So Gail, do we have any questions in chat that Kyla can answer for us?
No, I don't see anything. Does anybody have a question that they haven't typed in?
That's fine. You can certainly ask it after Michael's done. So with that, Michael, do you want to go ahead and get started? Kyla, that was marvelous. Thank you. Well done.
All right. Yeah, so can you all see that?
Yep.
Yep, looks good.
All right. All right, well, thanks everybody. And hello, my name is Michael Krochta, and I'm the Forest Watch Director for BARC. Those of you that aren't familiar, BARC's a local nonprofit whose mission is to defend and restore federal forests surrounding Mount Hood, including within the Clackamas River Basin. And over the years, my job has been mostly monitoring federally proposed timber sale projects, but over the last few years, I've been developing a beaver habitat survey and restoration program over at BARC. And I really did this through talking to a whole lot of people that knew a lot more about this than me. And on that note, as Dave mentioned, starting this fall, I'm going to be entering the Portland State University's Earth Environment Society PhD program this fall to further study some of the topics I'm going to be talking about right now. Before I get started, just want to again acknowledge CRBC and especially Dave Bugney for inviting us to speak today. So just a quick outline of what we're going to go over. We're going to get into a quick Beavers 101 and then go over some effects that beavers have on their environment, which will lead into kind of a brief history of from trapping to restoration on the Clackamas River Basin. And then that's going to take us to the beaver habitat assessment that we use as part of the project that Kyla had mentioned. And then that's going to lead into some beaver restoration approaches and efforts. This is that image that Kyla showed earlier of the wetland complex that's just north of the Little Crater Lake site. You can see this really long beaver dam that spans the entire wetland here at the top of that image. So today we're going to be talking about the American beaver, Castor canadensis, although there is a European variety too, the Castor fiber, which has a really similar life history and ecology. So actually some of the science I'm going to be talking about today actually comes from Europe as well. This is the current estimated range of the American beaver. There's thought to be around 6 to 12 million beaver on the continent now, compared to 60 to 400 million in pre-colonial times. Right now, beaver populations are actually increasing in the northernmost parts of their range as ice melts due to climate change, and also down in Patagonia, where they've been introduced and are considered an invasive species. And there's also a handful of American beavers that have been introduced in Europe as well, apparently. So just a little bit of basic beaver behavior, life history, and ecology. As many people know, beavers, they create and use ponds through building dams out of branches and other materials. And these ponds provide safe haven for them from predators. And then that flooding also increases the abundance of their preferred foods, which we'll talk about a little bit later, and then extends safe access to those foods, since they're really good swimmers, but are pretty clumsy up on land. And beavers also build these lodges out of branches and other materials that house a beaver colony. And you can see in this illustration that there's an above ground living quarters with an underwater entrance, kind of as an additional safety mechanism. And we'll look at some examples of lodges out on the Clackamas, but I'll just mention now that also bank lodges are common as well, especially along larger river segments. Basically the same idea with that underwater entrance, but they often utilize root wads along the banks as well to sort of reinforce those living quarters. Beavers are strictly herbivores. They get their nutrients from aquatic plants and the inner bark of trees. And they also acquire their building material by felling those trees. They have these really strong iron reinforced teeth that never stop growing. And so they need to constantly gnaw on wood to keep their teeth from growing too long. And along with that, they're really obsessed with the sound of running water, apparently. And there's kind of this legendary experiment that people might have heard of where a beaver was placed in a room with a speaker playing the sound of running water and ended up piling sticks all over it. I've never actually read that study myself, but it's a funny image to think about. Beavers are mostly nocturnal. And so most of the footage that you're going to see of them working is going to be at night. And these are some images some cameras that we set up outside of Colton got of a local beaver over on Milk Creek. Beavers are often called ecosystem engineers, and rightfully so. Other than humans, they really shape their environment more than almost any other animal out there. And they do this by damming up riverscapes, which set them on this trajectory from a very incised, single channel, low water table structure to more of a messy multi-channel system with a high water table and lots of structural diversity, which we'll talk more about in a bit. This is an image of Anvil Creek on the Oak Grove Fork of the Clackamas, where beaver have built this extensive complex of dams that has backed up this water for so long that it's created this permanently flooded wetland. It's formed behind all the dams. And this can occur on urban environments as well, and not without conflicts. This is an image of Errol Heights Park. This is on a tributary of Johnson Creek that's just changed dramatically from what it looked like before beavers went to work here. And it turned this more into a lake right up against some people's properties. And you can see here multiple beaver dams and a lodge that's out here in the middle of the water. And so this is all interesting stuff, you might say, but why do we care about this? Well, it comes down to the effect that beavers have on water and subsequently habitat as it relates to climate change. It's pretty well understood at this point that precipitation and temperature are going to look a lot different by mid-century. We're going to see more flood events along with more drought and forested ecosystems. And so, for example, in the Clackamas watershed, river flow in some areas it's already shifting from snowpack driven to more of a rain driven system from year to year. And that combined with more summer droughts, a real concern for both drinking water and salmon habitat. And since water is going to be moving more quickly through the watershed, it's going to be less available later in the year. We're also going to be seeing increased stream temperatures overall, which could mean decreases in viable fish habitat and, of course, more wildfires. Might be kind of hard to see on these maps, but these maps are from a recent Forest Service publication, which predicts a really significant decrease in summer river flows, as well as snowpack on the west side of the Cascades. And then, when you factor in the increased disturbances in the future, like what happened in 2020 in our area, we have a lot of thinking to do about how to best set up the watershed to become more climate resilient. And because we all know that the existing infrastructure likely isn't totally adequate to fully mitigate these impacts, and can itself have its own impacts, there's really a growing interest in the potential for natural infrastructure to maintain or enhance some of these ecological and social benefits that we've grown to depend on. And being beaver dam building ecosystem engineers, beavers are really gaining attention for their creation of this natural infrastructure, at least on a local level. These beaver maintain habitats that can slow down water through damming and through excavating small channels out from the main stem of creeks they live on, which can increase water storage and groundwater recharge. Due to that slower release of water and increased percolation down into the aquifers, and also what's called hyporheic flow, basically water moving horizontally out under the ground to increase the size of wetlands or connect riverscapes with other water bodies. And what this does is it can really moderate floods and keep water around longer in the summer months when drought's an issue. Here's a few recent papers that I added here on flow attenuation, similar to what Kyla was talking about earlier. These studies had to do with peak flows. And this graph here on the right shows basically variations in flow upstream and downstream of a beaver dam complex. And you can see there's quite an effect here. These beaver dams, they're not like human-built dams, they're leaky, and so they can really promote a slow release of water throughout the season, which can lead to increased base flows out of the site in the summer months. These dams can also filter sediments and intercept pollutants from non-point sources. There's a graph here and a photo taken from the same study showing that upstream and downstream comparison of total suspended solids surrounding a beaver complex. It's also been shown that in some cases, beaver ponds can moderate stream temperatures through an increased exchange in groundwater or a decreased surface to volume ratio. But there's kind of an assumption there that they are going to keep the water warmer in the winter, cooler in the summer. And there's been mixed results on that, depending on where you're looking at and what type of system there is. Included a few examples here of some recent papers on this. This graphic on the left shows higher variability of temperatures behind the dam, which that variability decreases above and below that complex. Whereas in this study here, this shows that sites that where higher beaver dam abundance existed, it was much less likely to approach lethal temperatures for juvenile steelhead. Counter this other study, there was less of a variation in stream temperature compared to sites where there were no beavers. So as we all know, the Clackamas Basin, it's really a changed landscape after the 2020 fires. We witnessed a preview of what's to come in terms of where and how wildfires can burn on the west side of the Cascades. And actually, there's some new evidence that beaver ponds can act as potential refugia during wildfires like this. Beavers, again, they build these dams, they build out channels, and change these small streams into broad wetlands over time that can keep plants green and more fire resistant during periods of drought, as shown in this conceptual diagram created by Emily Fairfax in this study that came out in 2020. This is a still from a viral video that she also created that's gotten a lot of attention since last year before the paper came out. Encourage folks to check this out. But her study has shown, using a metric of plant greenness acquired from satellite imagery, that streams with beaver dams were actually 3 times less affected by wildfires compared to those without beaver activity. That's pretty interesting stuff. Definitely a lot more room for research on this topic. These are some images from this one's from a flyover I was on shortly after the Riverside fire, showing a relic beaver dam here and some ponds. This area had some mixed severity fire impacts, and then we were able to revisit the sites a few times after. Here's just a few more photos. This one's a little over a year later, and then one again that was taken just last week. So beavers, along with being ecosystem engineers, they're also keystone species. Species that other species depend on in an ecosystem. And so much so that if they were removed, that ecosystem could really change dramatically. And the habitats that are created by beaver are really unique and valuable to other species. For example, all these dead trees along the edges of this opening were killed by flooding. These are providing really good habitat for insects, birds, mammals, and overall, beavers end up adding a lot of complexity. Wood and streams, creation of pools, that are important for salmon, amphibians, and waterfowl. Really, beaver and salmon co-evolved in much of their range. And salmon can really benefit from having deeper pools in some areas during those low water flows, as well as areas to escape during powerful high flows as well. And the expansion of wetlands also can provide crucial stopover sites for migratory birds like sandhill crane, which sometimes travel thousands of miles and depend on sites like these to be able to rest and refuel for their epic journeys. This is an image of me here setting up a camera at one of our sites within the Riverside burn. And another one of these cameras got an image of this pair of mallards that are floating around right next to a beaver dam on Milk Creek. Here we have newts that are breeding in the springtime at Tumala Meadows up in the Roaring River watershed. So yeah, like I said, beavers improve wildlife habitat, and so then fishing and hunting and birding opportunities can also improve with that in many areas. Just included a few more photos here. This is one I got of a fresh bear print over at Cottonwood Meadows a couple years ago, and then this is an image of a male elk that we got from one of our trail cameras just last week at the Pint Creek Beaver Dam. And so, you know, the fact that it took so long for many of these benefits to become broadly accepted and valued is kind of, it's an example of something called ecological amnesia, basically a concept of a once really commonly held narrative around the ecological process being largely removed and kind of forgotten about by the time contemporary ecologists started studying it. Again, like I mentioned earlier, there's an estimate of 60 to up to 400 million beaver on the continent in North America in pre-colonial times, and also an estimated 150 to 250 million ponds in North America, with an estimated 235,000 square miles of stream impounded. And these numbers are, it's a lot to imagine, and but they were significantly reduced through the European fur trade and beaver trapping, but also through farming and development on what used to be beaver occupied territories. This map here kind of shows a progression of trapping starting in the 1600s as it moved west across the continent. Just provided some great resources here if people are interested in learning more about, you know, historic trapping and how it really drove the history of colonization on this continent. And in the upper Clackamas drainage specifically, there's evidence of beaver trappers at Clackamas Lake as early as 1808. This carving was found there. It's included in this book, Tales of High Clackamas Country. I was just really surprised to learn that fur trappers had established themselves this high up in the basin, and doing so altered the landscape, you know, 100 years before the Forest Service started managing these lands. It was kind of, you know, talk about a shifted baseline. It was kind of mind-blowing to me. And, you know, although populations of beavers have increased throughout much of their historic range, after being trapped nearly to extinction by 1900, this long absence on the landscape, it was really a major factor and continues to be a major factor in the current degradation of many American riverscapes. However, as early as the beginning of the 20th century, there's been an understanding in some circles that beaver play a really critical role in the ecosystem, and a movement began to restore them back to their former range. You know, humans and beaver, they compete for the same habitat often, and when beaver move in, there's often flooding, plugging of culverts, damage to commercially valuable trees and whatnot. And so these problem beavers, in some cases, were caught and released elsewhere, which is obviously better than being killed. The photos here on the left were taken during a quote unquote beaver liberation in New York State, as far back as 1905 is when these were taken. And this image on the right depicts a program that actually happened in some of the Western states to airlift nuisance beavers to remote areas where they could do their work. And if you don't believe me, here's a photo of a beaver re-emerging from a box that was reached its destination via parachute. Pretty amazing. A few years back, while the Estacada Ranger District was kind of getting ready to move and going through all their archives, I was lucky enough to borrow kind of a treasure trove of maps and other information about beaver and beaver relocation in the Clackamas dating back to the early 1980s and even before that. So, you know, folks might recognize some of the names of these places and people from the Forest Service who were involved at the time in receiving beavers from private landowners and taking them up to the national forest lands. And, you know, there's some really interesting notes here about some ideal locations for beaver reintroduction and even some rough beaver population estimates on some of the sites that we've since become really familiar with. Like Kyla said, though, there's still continues to be a lack of beavers compared to what is thought to be historically present in Mountain National Forest. So BARC decided in 2019 to work through our volunteer fieldwork program to document beaver presence and habitat with the goal of identifying areas with high impact restorative potential. You know, and that might look like reintroducing beaver or restoring their habitat or otherwise giving the agency the information they need to be able to manage the existing populations that remain. So one of our partners, the Mapping Action Collective, provided a spatial analysis of the entire Mount Hood National Forest. It was based on a literature review that they did of beaver habitat suitability. And that included the BRAT model. This is a model that was developed by Utah State, a spatial model for determining suitability for dam building along rivers. And that along with a lot of this anecdotal information that we got from the Forest Service really were the two starting points for getting us out into the field. After that, we developed a volunteer program to assess and prioritize habitat suitability for beaver using this scorecard on the left here, which we're going to go through in a minute. And we developed that sort of in communication with folks who had pulled off similar work up in the places like the Methow Valley up in Washington and other places too. So here's a map similar to the map that Kyla showed earlier, showing all the surveys that were completed as of 2020. So this one's a little bit behind with our mapping, but you can see where these sites are as they overlap to the 2020 fires. You know, these colors here refer to some of the scores that were provided by the field surveys done by volunteers. And so I'm going to be talking a little bit now about that survey protocol by breaking out that scorecard, which we use to rank our sites. And so we're going to just quickly walk through that together. The first thing we do is our initial screening. So we want to make sure that we know whether there is potential conflict that would prevent a long-term beaver family from establishing at the site that we're looking at. So some examples are, you know, culverts under main roads that could be plugged, buildings that could be flooded, or a campsite, for example. And we also want to know whether a beaver is already present in the area. And you can usually tell this by looking at the chewed wood that you find. You can see that this wood, this beaver chew, is all really light colored, it's fresh, the wood hasn't faded or split compared to this chew, which is obviously much older. And so now begins the scoring part. So we want to know if there have been beavers at the site in the past and what that looked like, since that can indicate good habitat. And the more that we find, the higher score that site is going to get. This is a classic dome lodge that's at the edge of a lake. Some more examples of lodges here. Here's one utilizing some live trees. This one's kind of on an island, which allows the beaver to keep predators at bay. Another example here of the same kind of thing. This is again over on Milk Creek in Colton. This beaver lodge here, taken from above, the Little Crater Lake Meadow Complex. You can see there's actually like moats that have been excavated in this area to sort of provide that safety mechanism. And you can see there's probably multiple entrances to this lodge. So dams are also something that we're noting. This is a classic beaver dam here that's holding back water and creating this pool behind it. They can come in many different sizes. This one's a really large dam compared to this one's really pretty small, probably only about 1 foot wide. You'll also see beaver excavated canals extending out of the main stem of creeks or ponds. And in this case, this is one that was excavated to dig out some access, some safe access to some food that was along the tree line here at Clackamas Lake. Speaking of that, beaver's favorite food, as many people know, is willow. Alder is kind of a secondary food, and there's a lot of other ones too. Hardwoods, mostly cottonwood, dogwood, and aspen are some examples. Here's some beaver with some willow. It really seems to be, willow especially, one of the limiting factors in some of the areas where beaver are present, but they aren't now. So along with that woody food, beavers also throughout the year need to have some fresh greens. And so, this part of the forum asks us what the cover of herbaceous non-woody food is around the water at the site that we're looking at. And on top of being an important food, those woody plants are also used for building lodges and dams. And beavers typically use woody materials that are between 1 and 6 inches in diameter for that building. And along with the sticks, they also use a lot of mud in their dam and lodge building. And so, and they also need to be able to excavate to build out their ponds. And so mud or muck is really the best for this. And you can usually see the bottom, the substrate of the stream or the pond that you're looking at. And if you can't, you can always probe it with a stick and find out what the main substrate is there. Again, beavers, they use these pools to take cover from predators. And so, predation, it can really be a limiting factor at a site, especially if there's no existing pools. It makes them really vulnerable. And so this is water cover is something that we pay very close attention to when we're doing these habitat surveys. Here an example at Anvil Creek. There's these very large ponds that are supporting multiple lodges and allowing connectivity between them for beavers to move safely. And then floodplain structure. This can really influence how much water can be dammed up at a site. And it's much better to have a wide floodplain so more flooding can occur over a large area. This whole thing, this is a beaver dam, and which had to be built outward from what was probably originally a riparian area over many years to hold back all this water that it's holding back now. And so it's good in this case that the beaver had a lot of space to be able to do that. Compared to a situation like this, where you've got this really steep bank on this side, this site has a much higher potential for blowout during high flows. Here's another example of a floodplain which has facilitated sort of this braided channelization and lots of room for lateral expansion post beaver damming. We also measure the slope of our site. So again, the gentler the slope of the stream, the easier it's going to be for the beaver to dam it up, and the more success that beaver is going to have in creating more water cover. And then the last thing we look at is discharge out of the site. So estimating that amount of discharge, if there's too little, there's not going to be enough water to dam up, especially later in the season. And then if there's too much, that dam won't be able to hold it back. Generally you should be able to easily wade through the site. And if you can't, a beaver, it might be able to still persist there and in a bank lodge or something like that, but it might not be the best place to promote beaver if you're specifically interested in increasing water storage and wetland size. So, all of these things combined. Oh, I should also say this bell curve kind of describes that here. How we usually rank discharge, and the sweet spot being this year-round flow but never destructive, kind of similar to a 10-inch to 30-inch pipe, depending on the time of the year. And all these things combined will give us our score for a site. But again, it's really important to remember that a lower score doesn't necessarily mean the site can't be restored. Depending on whether there is a missing link for good habitat, we'll be recommending different restoration techniques. And so let's talk about what some of those might be. First, I just thought I'd share a couple of free resources that are available online as PDFs that I felt really helpful and interesting. And if you look these up and you can't find them, just let me know and I can share a link with you. But one really simple restoration technique that we've actually begun to use is simply transplanting willows to areas that they're lacking. And the idea being that if you build it, they'll come. And we've done this at a few locations, including Sam Creek Meadow, which is depicted here. Also at Pint Creek and Stone Creek, and I hear that there's a Cub Creek transplanting that's in the works. So at Sam Creek, this is an aerial image of Sam Creek. This meadow was flooded in the past, but the Beaver Dam, which was over here on the right-hand side, has since been breached. And most of the willow was on this opposite side of this site. Most of this over here is alder. And so what we did was we took about 400 cuttings from this side of the meadow and just simply transplanted them where the water cover and the old Beaver Dam was. And that was something that we did in collaboration with the Forest Service. And this is kind of what that looks like. So, anybody can do this on your own property if you'd like to, just taking fresh willow stems here. You want to do this in the late fall. And then, just simple as sticking them in the ground to a certain depth. And, a year or two later, you got fresh shoots and more willow where you want there to be. Another technique that's becoming more common is to build what are called beaver dam analogs. So these are artificial starter dams, basically for beavers to build off of. We haven't experimented with these yet, but apparently something like this is going to be done up at Tumala Meadow, up near the North Fork. Basically what this is, it's taking untreated posts and weaving willow through them to promote dam building in areas where that's desired, and that gives beavers kind of a head start on getting that water cover established. There's been a lot of studies done on the effectiveness of these and whether or not they allow fish passage, and most of what I've read really points to their value in many cases. I'll just mention also, these types of human-built structures aren't new or necessarily specific to places that beaver live. This book on the left here really gets into a lot about wooden and stone structures that have been used for a long time in arid ecosystems that effectively do the same thing to raise the water table. And this photo here on the right is taken of a brush dam, I think in Arizona, that was developed by the Zuni people as part of a practice to increase soil infiltration and reduce in-channel erosion. So pretty interesting. And then another restoration technique is to exclude trapping in some areas. And this can be really controversial. And it's been the topic of a fierce debate in recent years. And actually the federal lands in Clackamas County are some of the only places in the entire state where trapping is currently prohibited, as shown here. So these blue areas here are areas on federally managed public lands that are closed to beaver trapping as opposed to the orange streams. In 2021, there was actually a legislative effort to close federally managed public lands in Oregon to beaver trapping, which would have resulted in something that looked something like this. And this was actually one of a few beaver bills that were proposed for the 2021 legislative session. Banning beaver trapping on federally managed lands was one of them. Also removing the predatory status, which under the Oregon statutes allow beaver to be killed with very little oversight. And then also providing funds for landowners for non-lethal control methods. None of these ended up getting traction in the 2021 session. However, some of these concepts are coming back, and there's just a few things here for people to keep track of. One of which is the new Oregon Private Forest Accord. There's a number of provisions in this document related to beaver and management of beaver on private lands, and just a lot of really great information about beaver in general. So definitely encourage folks to check that out. And then if people are interested in the trapping conversation specifically and what's going on with that, the ODF&W Beaver Work Group has been meeting since last summer to try to come up with agreements and recommendations to the Fish and Wildlife Commission on this topic. And they they live stream all of their meetings, which are all pretty interesting. And the next one is going to be on April 13th from 9 a.m. to 12 p.m. This is just a outline of their schedule showing that I think they are on schedule to then present their recommendations and have some public input on that at the May 13th Fish and Wildlife Commission meeting. So with that, I'll just say thank you again to all of our partners and funders and move on to our Q&A.
Okay, Cheryl, do we have any questions in the chat? Let's see.
We do have a request for links to the manuals you mentioned for Michael Krochta. And this request came from Eric Butler, who indicates that for those of us who are interested, could you please post links to those two manuals in the chat? And then there's an exclamation of Bridge Creek. There is a question from Edith Thurber. Are beaver predators?
They are not predators. So it's a very strange and outdated statute that defines them as predators in Oregon. Yeah, like I said, they are strictly vegetarian. So I am not sure where that designation came from, but it's one of the things that folks are actively trying to change. And yes, I'm going to put some of those manuals in the chat here.
Thank you, Michael.
That'd be great. Well, if there aren't any other questions, I'll just wrap it up here for today. First off, I want to thank both Kyla and Michael for an awesome presentation. It's one I've been waiting for, and they delivered as far as I'm concerned. Great job. So thanks again. And our next session will be on April 19th, so 2 weeks from now, but at 2 p.m. in the afternoon, not 6 p.m. And we'll continue our series focusing on water and fish. And we'll focus on large-scale fish habitat restoration plans within the Clackamas River Basin. And you can use the same Zoom meeting link and are already registered for the event. So we'll send you a reminder email a day or two before. And I just want to remind folks before you jump off that the CRBC will be having a free Healthy Streams and Forest class out at our place this Saturday from 9 to 12 noon. And I can guarantee you that you'll see some things that most likely many folks have never seen before, and including some of the things that Kyla and Michael were presenting tonight about beavers and wetlands. So if you're interested in that kind of thing, as well as fish habitat restoration and sustainable forestry, consider signing up and coming on out. And then we'll send you a thank you email with these links, as well as a link to the recording and more information about the continuing education credits. We'll also thank our gold sponsors, Oregon Beverage Recycling Cooperative and the Clackamas Water Environment Services, and our bronze sponsors, the Clackamas River Water Providers, Metro Port Blakely, and the Geological Society of the Oregon Country, who are helping us keep this conference free for all participants with their support. So thank you again for joining us tonight, and let you know what you think. And hopefully we'll see you 2 Tuesdays from now at 2 p.m. on April 19th. So thank you for showing up, everybody. Thanks again, Kyla and Michael. God, this was great.
Very good. Very good. Thank you both. Kyla, there's so much to think about from your presentation to be able to formulate a question. Wonderful. Michael, it's so great to see all those sites in the Clackamas Basin that you've been able to access. Thanks for those features.
They are some cool areas. Yeah, and if anyone's interested in visiting them, yeah, get in touch with us because we go out there quite a bit.
Michael, did you happen to mention what numbers of beavers supported by certain size of dams, or that whole stretch at Anvil Creek? What you'd estimate would be living in that area? Well,
I don't know. What do you think, Kyla? I've seen at least 3 separate lodges in that one stretch of Anvil Creek. And so, you know, that tells me that there's at least 3 families. And so, you know, that could be up to 10 or more beaver, depending on, you know, if the kits are around.
Are those, were all of those lodges active? Could some be holdouts from earlier times? Because there's the collection of dams sort of piled up near the outlet, which maybe some weren't as effective. And so one family started adding more and more until it started to really back up that system.
Yeah, that's true. Yeah, there's those that are kind of all clustered together, and then there's some more that are sort of along the, I guess, the bigger the ponds, you know, the larger water cover. Yeah, I mean, it's in general has been, I mean, you notice the wild range of estimates for beaver populations. Like it's Oregon especially seems to have not done a very good job of providing very good estimates of populations. But I mean, that's also kind of across the board. They're really elusive creatures, and will, like Dave, like you mentioned earlier, they'll move from site to site, from year to year, based off of the food that's there, or, you know, any number of factors. And it can be really hard to keep track of how many beavers are actually at a site at any given time.
I was wondering, Michael, have you gotten it all into like, so it seems with many mammals, we're interested in what's happening with the population. They're often some capturing and some marking and maybe installing of radio devices. Is anybody doing that sort of telemetry work with beavers that you know of? Yeah,
I know that there are a number of people doing that. And then there's also people working with eDNA in some places. And like there was a study that came out this year on the Coast Range that Vanessa Petro and others at OSU did, where they, I think that they used eDNA to really in detail give some estimates over a sub-watershed of, you know, where beavers were and how wide ranging they were and everything like that. But it hasn't been something that's like a broadly applied program by any means, I don't think. See, Taylor, you have your hand up.
Thank you for your conversation. It's generating some questions. Taylor.
Nice.
Thank you. My girls and I enjoyed the presentation here. Thanks. No, the question was really, and maybe it's too soon to say or hard to get the information, but wildfires and beavers, right? So, you know, do we see kind of any correlation in terms of how far wildfires affected things versus, well, hey, these areas seem to have been protected by the beavers?
Yeah, there's well, so that paper that I showed some results from, that was a study that was done across several states, looking more at riparian areas that were impacted by beavers, right? Kyla's been like good to point that out, that there's, you know, like she did in her presentation, there's kind of a difference between the more palustrian versus riparian sites and what you could expect there. I think
too, with Emily Fairfax's work so far has been in more arid environments. So the photos that Michael showed are from like a sagebrush steppe environment, where the fuel is that sagebrush and the grasses, right? Well, here on the west side, of course, the fuels are mainly the trees, and the fire, at least the riverside fire, was spreading from canopy to canopy. And so in that respect, it seems like things like the wetland size or the beaver habitat area is going to be super important, right? Whether the width is enough to prevent fire from jumping from one section of forest to another. And it's kind of a different setup when we're looking at the different surrounding ecosystems. So again, whether forested, whether it's sagebrush, whether it's grassland, whether it's wetland where the soils have really dried out, and then that organic matter can be fuel as well. So a lot of different components there, but lots of interesting questions to try to tackle.
Yeah, and it's one of the things that I'm really hoping to explore more through my future involvement at PSU. I think that given that we've had these recent wildfires on the Clackamas, overlapping with a lot of wetlands and beaver habitat, there could be some really interesting questions to investigate there. And it does seem like, you know, that Emily Fairfax's study and some others that seem to be going on right now up in the Methow Valley are focused on a much different ecosystem than what we're talking about on the west side of the Cascades and on the Clackamas. So we'll find out.
And Kyla, it was wonderful to see your presentation on areas that were around the wildfire. So more current information that you were able to display, and kind of some surprising results of the depth and what changes you were seeing in those wetland areas. I have to go back to that to digest it. As I said, there's certain elements of your presentation that deserve a second or more go through to generate a question.
Yeah, well, I'm glad you all are recording these and that they're available to such a wide audience. So folks can go back and spend a little bit more time on some slides if they're interested. And I too am really interested to see what the data look like from all of the sites, to see, you know, if there's synchrony in some places. We're definitely seeing a synchrony in water temperature across the wells. So there's fluctuations up and down that are common more so across sites, a little bit less with the water levels.
Mm-hmm.
Thanks again, you all. I'm gonna head out. So, hey, stay in touch.
Will do.
Thanks
For having us.
Thank you so much.
Bye-bye.
Thanks.
Have a good night.